In today's lesson, we're going to solve quadratics by completing the square. This is just another method that you can use to solve quadratics. It's not really my favorite method because there's a really long process, but I'm going to show you this process now. The main goal of completing the square is we're going to create a perfect square trinomial so that we can manipulate the equation and make it look something like this, where we have an expression in parentheses and the exponents on the outside equals a constant on the other side. So here's the steps that you're going to use to solve. First, you're going to write your quadratic in standard form. So as you can see, this is already written in standard form. X squared plus 4x minus 5 equals 0. The first thing that you're going to do is move the constant to the right side of the equal sign. So how do I do that? I add 5 to both sides and I get x squared plus 4x equals 5. Then in order to create your perfect square trinomial on the left side of this equal sign over here, you're going to add b over 2 squared to both sides. And the reason you're going to add it to both sides is because in order for this equation to stay balanced, what you add to the right side or the left side, you have to add to the right side. So b over 2 squared. In this situation, b is 4. So b over 2 squared is not 2 over 2, I'm sorry. It's just 2 squared, right? Because 4 divided by 2 is 2. 2 squared, which is 4. So we're going to add 4 to both sides. And what do we get? We get x squared plus 4x plus 4, which is a perfect square trinomial. What do I mean by perfect square trinomial? I mean x plus 2 times x plus 2, right? That's a perfect square. Those are the same. The binomials are the same. Equals 5 plus 4 is 9. And then we're going to factor, we factored that perfect square to get x plus 2 times x plus 2, and I'm going to rewrite it like this. X plus 2 times x plus 2 is x plus 2 squared equals 9. So now that's how we manipulate our equation to make it look like that. Now what we can do, your main goal is to get x all by itself, right? That's what you're doing whenever you're solving an equation. You're getting the variable all by itself, x equals blah, 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 blah. So the next thing I need to do is get rid of that exponent of a 2. How do I undo a square? I take the square root of both sides. That's your next step. We're going to take the square root of both sides. But when I do that, that undoes this square over here, right? They cancel out, right? If I take something and I square it and then I take the square root of it, I'm back to where I started. So I get x plus 2. But if I take the square root of 9, I actually am going to get a positive or a negative, right? Because if you think about it, and we know the square root of 9 is 3, right? But 3 squared is 9, but negative 3 squared is also 9. So whenever we're undoing that square root, you always need, and you're working in an equation, like you've got an equal sign in your problem somewhere and you're undoing a square, you're using a square root, it needs to be positive or negative, okay? Yesterday when we talked about simplifying non-perfect square roots, and I just asked you, what's the square root of 36? I'm asking for the principal square root. That's always positive. When you're working in an equation and you're undoing that square and you're using that square root, you're going to have a positive or negative sign. So now, remember the goal is to get x all by itself. So how do I get x all by itself? I'm right here. How do I get x all by itself? I'm going to subtract 2 from both sides. What does my expression look like on the right side? Negative 2 plus or minus the square root of 9. Well, I can write it as two equations. Negative 2 plus or minus the square root of 9 is the same thing as negative 2 plus the square root of 9, or negative 2 minus the square root of 9. What is the square root of 9? It's 3, right? So what we've got here is x equals negative 2 plus 3, which is 1, or x equals negative 2 minus 3, which is negative 5. I've got two answers here. X could be negative 1 or x could be negative 5, and if I plugged those into my original equation, both of those would work. So you can always write your answers like this. -5, or 1. Let's move on to the next example. When you're solving by completing the square, let's do another example that looks a lot like what we just did. So this is example number 1. I've got x squared minus 8x minus 16. My first step is I'm going to move that constant to the right side of the equal sign. So x squared minus 8x equals positive 16. And now I'm going to add b over 2 squared to both sides. So what I'm going to do here is I'm going to write this. Plus a blank equals 16 plus a blank. And I'm going to add something there. I'm going to add b over 2 squared to both sides. So that's really important to remember. B over 2 squared. That's -8 over 2, which is -4. -4 squared is positive 16. So I'm going to add 16 to both sides. Now I've got this perfect square trinomial on the left side, right? What numbers multiply to 16 that also add to -8? -4, right? -4 times -4 multiplies to positive 16, and they also add to -8, equals 16 plus 16 is 32. So now I'm going to rewrite this again as x minus 4 squared equals 32. And now we're back to where we want to get rid of that square, that 2. How do I undo that raising x minus 4 to the power of 2? I take the square root. What I do to one side, I have to do to the other. And I'm left with x minus 4 equals positive or negative 32. I'm sorry, square root of 32. Square root of 32 is not a perfect square. So we actually need to simplify this. And I'm going to work this off to the side. The square root of 32. How can I simplify the square root of 32? What's the biggest perfect square that goes into 32? It's 16. 16 times what? 16 times 2. So I can rewrite the square root of 32 as the square root of 16 times the square root of 2. What is the square root of 16? It's 4. So I can rewrite this expression, positive or negative square roots of 32, or square root of 32, is the same thing as positive or negative 4 square roots of 2. So let's rewrite all of this. X minus 4 equals positive or negative 4 times the square root of 2, or 4 square roots of 2. Remember, our goal is to get the variable all by itself, so I need to add 4 to both sides. So I get x equals 4 plus or minus 4 times the square root of 2. If you're ever confused, I would suggest, let me change colors here, replacing that radical little portion of your number with a variable, right? So this positive or negative 4 square roots of 2, positive or negative 4x, right? If I add 4 to both sides, I get 4 plus or minus 4x, right? And it's the same thing. It's just 4 plus or minus 4 square roots of 2. But I'm not done, right? What would you do in this case over here? You could factor out a 4, right? So I could factor out a 4, right? If I did it over here, I'd be left with 1 plus or minus x. Same thing over here, 1 plus or minus the square root of 2. And there's your answer. X equals 4 times 1 plus or minus the square root of 2. And because you have that plus or minus, you have two answers, right? You have 4 times 1 plus the square root of 2, or 4 times 1 minus the square root of 2. But this is how you would write your answer as the simplified square root. Let's move on to the next example. Solve when a is not 1. So in this case, you have a leading coefficient that's not 1, right? We have a 2. So our note right here says, after moving the constant to the right side of the equal sign, divide all terms by the coefficient of the first term. Okay, so let's first do our first step of 2x squared plus 6x. We're going to move that constant to the right side of our equal sign, equals 26. And then now we want to get rid of that coefficient, so we're going to divide every term by that leading coefficient. That gets rid of that. So now we have just an x squared in our first term, plus 6x divided by 2 is 3x, equals 13. And now I'm going to add b over 2 squared to both sides. So I'm going to add, what is that number going to be? B over 2 squared. That's what we're wanting to find. B over 2 squared. B over 2. This is our new B, right? 3 over 2 squared. Oh, lovely. 3 over 2 squared, where we're just going to apply using our exponent rules. That's the same thing as 3 squared over 2 squared, which is 9 over 4. We're going to add 9 over 4 to both sides. Ooh, lovely, lovely. Okay, moving on. Whenever I am asked to square or factor this perfect square trinomial, it's just my middle term, that b term, divided by 2, right? So if b is 3, when I factor that perfect square trinomial, it's going to be x plus b over 2 squared. So x plus 3 over 2 equals 13 plus 9 over 4. Okay, well now, let's do this off to the side. 13 plus 9 over 4. Well, I'm adding fractions. What do I do when I'm adding fractions? I get a common denominator. 13 over 1 is the same thing as what over 4? 13 times 4, which is 52. So I'm just rewriting numbers with a common denominator, and now that I've got that common denominator, I can add the numerators, keep the denominator. 52 plus 9 is 61, and I get 61 over 4. I know it looks ugly, but I'll show you. We'll work through these problems together, and you'll be perfectly fine. So what's the next step at this point? I need to get rid of that square. How do I undo that square? I take the square root of both sides. So now I'm left with x plus 3 over 2 equals the square root of 61 over the square root of 4. And I'm actually going to write it like this. Square root of 61 over the square root of 4. That means the same thing, right? The square root of 61 over 4 is the same thing as the square root of 61 over the square root of 4. So I can write those, they mean the same thing. Let's simplify this even further. Okay, x plus 3 over 2. Can we simplify the square root of 61? Is there a perfect square that goes into 61? There is not, so I can't simplify the square root of 61. Can I simplify the square root of 4? I sure can. It's 2. Okay, so remember our goal is to get x all by itself. We've got x plus 3 over 2. How do I get rid of that 3 over 2? I subtract 3 over 2 from both sides. That gets rid of it from the left side, and I get negative 3 over 2. Oh, you know what? I never wrote plus or minus. I should probably write plus or minus over here. Plus or minus the square root of 61 over 2. Sorry about that. Plus or minus. Need to have your plus or minus there. So negative 3 over 2, follow me right here. I'm going to move it up to here. Negative 3 over 2 plus or minus the square root of 61 over 2. I can combine my numerators just like we did up here, or right here. I can combine my numerators and keep my denominator. So let's do that. Negative 3 plus or minus the square root of 61 over 2. And that's my answer. Equals x. What does that mean? X equals negative 3 plus the square root of 61 divided by 2, or negative 3 minus the square root of 61 divided by 2. So if you ever want to find like the decimal, right, because this is just a number, right? The only thing is when you've got a square root in there, this tends to be like that's your exact answer. If you write your answer as a decimal, you'll typically take it out 3 decimal places. That's what it'll want you to do on your AP exam if you ever go to AP Calculus. Take it out 3 decimal places, but you're going to be rounding, so it's really an approximation. But if you were going to do that, make sure you put this in parentheses in your calculator, negative 3 plus the square, and this is what you do. Negative 3 plus the square root of 61, arrow out, close parentheses, divided by 2. That would be one answer. Or negative 3 minus the square root of 61, arrow out of your radical, close your parentheses, divided by 2. And you'll have two decimals. You'll have two answers. But you can write it like this as a simplified square root, and that's perfectly fine. Let's move on to our next example. This looks kind of similar to example number 2 in that we don't have a leading coefficient of 1. Our leading coefficient in this case is negative 1. So again, after moving the constant to the right side of the equal sign, we're going to divide all terms by negative 1. So I've got negative x squared minus 5x equals positive 6. I moved that term to the right side. I'm going to divide every term by negative 1 because I want my leading coefficient to be positive 1. When I do that, and I'm going to write it out so you can see every term is divided by negative 1, I'm left with x squared plus 5x equals negative 6. And now we're going to add b over 2 squared to both sides. So x squared plus 5x plus whatever b over 2 squared is equals negative 6 plus whatever b over 2 squared is. So let's see, what is b over 2 squared? B in this case is 5. 5 over 2 squared is again 5 squared over 2 squared, which is what? 25 over 4. So I'm going to add 25 over 4 to both sides. It seems scary, but this is really similar to the one that we just did. And again, we'll work through it together. So now I've got this perfect square trinomial over here. Let's factor it. How do I do that? I've got b. If b is 5, then this is going to factor as b plus 5 over 2. And how can you always check your work? Where 5 over 2 times 5 over 2 is 25 over 4. And that's how we do that. 5 over 2 plus 5 over 2 is 10 over 2, which is 5. So now let's move on to the right side of our equal sign. Negative 6 plus 25 over 4. Okay, I've got an integer and a fraction. I need to get a common denominator. That denominator is going to be 4. Don't have to change this fraction on the right. What's my numerator going to be on the fraction on the left? Well, if my denominator is 4, I multiply it. Remember, that's just like negative 6 is just negative 6 over 1, right? I multiplied 1 times 4 to get 4. So negative 6 times 4 is negative 24. When I add these two fractions, negative 24 plus 25 is 1 over, leave that denominator, 1/4. So negative 6, so this is going to be positive 1 over 4. Okay, now we've manipulated our equation to the point where we need to get rid of the square on the left side of our equal sign. How do I undo that square? I take the square root. What I do to one side, I have to do to the other, and I'm left with x plus 5 over 2 equals positive or negative. I didn't write that when I should have on the last example. Positive or negative, and I'm going to write it like this, square root of 1 over the square root of 4, because I know that 4 is a perfect square. And I'm actually going to simplify that now. X plus 5 over 2 equals positive or negative. Can't simplify the square root of 1, but guess what? Square root of 4 is 2. What do I do at this point? If your goal is to get x all by itself, I need to move that plus 5 over 2 to the other side. How do I do that? I subtract it. Negative 5 over 2, right? If it's positive on the left, it's negative on the right. Negative 5 over 2. And then I'm just going to rewrite this plus or minus the square root of 1 over 2. But this is going to be really nice and easy, right? Because I have the same denominator, which is a 2. So I can combine what's in my numerator, negative 5 plus or minus the square root of 1 over 2, and that equals x. And again, if you want to plug it into your calculator and approximate your decimal value of this, let's see. You would do negative 5 plus the square root of 1, arrow out, close parentheses, divided by 2, or negative 5 minus the square root of 1, arrow out, close parentheses, divided by 2. And that would give you your decimal, right? But you would need to round it. because those, if you take the square root of a non-perfect square, it's an irrational number, right? So it never ends and it never repeats, so you've got a round. Let's go on to, is this our last problem? This is our last problem. This is the challenge. Okay, here we go. This is the challenge. What are we working with here? Let's just follow the steps that we know how to do, right? This is written in standard form. Again, this is not like my favorite method or favorite way to solve. I would probably use the quadratic formula on this given any other situation, but I'm showing you how to complete the square. So here we go. I'm going to move that constant to the right side of my equal sign. I need to get rid of the leading coefficient, which is 4. So what do? I divide every term by 4. That gets rid of that right here. Oh, but this is not a pretty x value. I'm going to go ahead and write this. Equals 8 divided by 4 is 2. So I kind of combined the steps here. I did the plus whatever I'm going to do, which is b over 2 squared. I'm going to add that to both sides. So in this particular case, now I have a b value that's not an integer, okay? It's a fraction. It's 9 over 4. So b over 2 squared looks a little different. It's 9 over 4 divided by 2 squared. Okay, well, what is 9 over 4 divided by 2? Well, let's think about this. 9 over 4 divided by 2 over 1. Copy, change, flip. Okay, I get 9 over 4 times, flip it, 1 over 2, which is 9 over 8. So what am I going to be doing? I'm going to be squaring 9 over 8, which is what? That's the same thing as 9 squared, which is 81, over 8 squared, which is 64, and that is what I'm adding to both sides. And it seems scary, but we're just going to follow all the rules that I have just laid out for you. Okay, we're just going to follow those rules. So we have our perfect square trinomial on the left side of this equal sign. How does that factor? X plus, right, because this is a plus, x plus b over 2. Well, we already know what b over 2 is. It's 9 over 8. So x plus 9 over 8 squared equals, okay, 2 plus 81 over 64. I need a common denominator, which is obviously going to be 64. 2 over 1 is the same thing as what over 64? 128. So now 128 plus 81 is going to be what? 209. Okay, if you need to like write that off to the side, you can do that. But that's 209 over 64. Whew! Don't let it scare you. We've got this. Okay, 209 over 64. All right, the next step, what do I do next? I take the square root of both sides. Okay, so now we have x plus 9 over 8 equals positive or negative square root of 209 over square root of 64. Okay, I'm really happy because I know that 64 is a perfect square. Okay, so let's just kind of work some stuff out here. X plus 9 over 8 equals positive or negative 209 over square root of 64 is 8. So what you might want to do is off to the side, square root of 209, try to think about, can you simplify this? It's a really big number. You'd like to think that you can, but is there a perfect square that is less than 209? Obviously is what it would be. Is there a perfect square that's a factor of 209? There isn't. So you actually can't simplify it. So let's move on to our next step. The goal is to get x all by itself. How do we do that? We subtract both sides by 9 over 8. So negative 9 over 8 plus or minus the square root of 209 over 8. Whew! Okay, here we go. Almost done. That's the same thing as negative 9 plus or minus the square root of 209 over 8. And that is my answer, equals x. Let's write it like that. And we'll write it like that. And that is my answer, is a simplified square root. Again, if you're needing to find the decimal value, you're going to have two cases. One where you're -9 plus the square root of 209, close parentheses, divided by 8, or it'd be -9 minus the square root of 209, close parentheses, divided by 8. And you'll get those two decimal values. But in most cases, you'll need to solve using simplified square roots. And that completes your very difficult notes over solving a quadratic by completing the square. I hope it was helpful.